এই ভিডিওতে আমরা ডিসকাস করব কিভাবে একটা ডিসি সার্কিটে যদি মসফেট থাকে তাহলে আমরা সেগুলা সলভ করব। তো ইউজুয়ালি যে কোনো নন লিনিয়ার ইলেকট্রনিক কিংবা ইলেকট্রিক্যাল ডিভাইস দিয়ে আমরা যখন সার্কিট সলভ করি তখন আমরা মেথড অফ অ্যাজিউম স্টেটস এর টেকনিকটা ইউজ করি। এই টেকনিক 3 স্টেপে আমার সার্কিট সলভ করতে বলে। The first step is to assume a mode of operation of the nonlinear device. The second step is to solve the circuit given our initial assumption, as per our initial assumption. And the last step is to verify the solution of the circuit based on our initial assumption. এইটার পরে আমার ভেরিফিকেশন আইদার ফেল করতে পারে, যেটা হলে আমরা আবার আমাদের অ্যাজাম্পশন রিনিউ করে আবার 3টা প্রসেস ক্রোনোলজিক্যালি সলভ করব। কিন্তু ভেরিফিকেশন যদি কারেক্ট হয় তাহলে আমার সার্কিটের সলিউশন আমরা পেয়ে গিয়েছি। সো এই প্রসেসে আমার হয়তো কোয়াড্রেটিক ইকুয়েশন সলভ করা লাগতে পারে, বিকজ ট্রায়োড অ্যান্ড স্যাচুরেশন রিজিয়নে কারেন্ট ইজ a quadratic function of either gate voltage or the drain to source voltage. আমরা কোয়াড্রেটিক ইকুয়েশন সলভ করার পর যদি দুইটা রুট পাই তাহলে আমরা সেই রুটটা চুজ করব যেটা আমার অ্যাজাম্পশনের জন্য ফেভারেবল। ওকে, so let's get started with some examples. In this example, we have a MOSFET circuit that has the following parameters, where the threshold voltage is 0.2 volt and the MOSFET transconductance parameter is 4 milliampere per volt square. So the question is, or the task is, to solve this circuit to find out the voltage VO2 and to find out the current ID. So it is usually a good idea to eliminate any assumptions initially, or any assumptions that we might have. So firstly, we have VO1 equal to 1 volt. Clearly this is greater than the threshold voltage of 0.2 volt. Now since the gate to source voltage of this MOSFET, which is basically VO1, is greater than the threshold voltage, we can say for sure that this MOSFET is definitely not in cutoff mode. Since this MOSFET is not in cutoff mode, it can either be in saturation or triode mode. Now, usually, it is a good idea to assume saturation mode of operation as our initial assumption. Now, why is that? It's primarily because the current for saturation mode of operation is much simpler than the current that we have for triode mode of operation. And if we have a possibility of our initial assumption to be wrong, then it's usually a good idea to opt for an easier solution rather than a much more complicated equation, right? Because we have that possibility of our solution being wrong. So if we assume saturation mode of operation, then clearly VO1 is greater than the threshold voltage, and VDS, which is basically the voltage VO2 in this circuit, should also be greater than the overdrive voltage defined as VGS minus VT. Now VGS is 1 volt and VT is 0.2 volt. So VGS minus VT is clearly 1 minus 0.2 or 0.8 volt. So if we solve the circuit, we can write down the equation of the current through the MOSFET, that is ID, as K over 2 times VGS minus VT whole squared. Now if we plug in the values of K, VT and VGS in this equation, we get the value of the current ID. For this value of ID, we can easily calculate the voltage at the node VO2, at the node which has a voltage of VO2, and the current value becomes 2 minus ID that we can find from this region of the circuit, and we find that the voltage is 0.72 volt. Now let us verify whether the assumptions that we made initially, that the MOSFET is in saturation mode, actually holds true or not. Now the drain to source voltage across the MOSFET is defined by the voltage VO2, And for saturation mode, this voltage must be greater than 0.8 volt. But from our solution, we find that the drain to source voltage is actually 0.72 volt. This voltage is actually less than 0.8 volt. So clearly, the drain to source voltage is not greater than the overdrive voltage of 0.8 volt. And that is why the condition or our initial assumption is not correct, right? So the MOSFET is not in saturation mode, but it is rather in triode mode. So what we can do now is plug in the equation of the current flow through the MOSFET in triode mode, and thereafter plug in the parameters of the MOSFET to this equation. Now what we find is that we know the value of K, we know the value of VGS, right, because we know VO1. We also know the value of the threshold voltage Vt. However, VDS is an unknown voltage. So how can we solve this problem? Now we can write down the value of the current ID as per the Ohm's law applied across this 1 kilo ohm resistance. Now, what is the value of ID according to Ohm's law? According to Ohm's law, ID will be equal to 2 minus VO2 divided by the resistance 1 that we find here. If we equate this with the expression of current ID, we find that VO2 can have two possible values. It can either be 1.37 volt or it can either be 0.73 volt. Now, we have to remember that we assumed triode mode of operation for the MOSFET. That is, this voltage VO2 should be less than 0.8 volt. But if VO2 becomes 1.37 volt, then clearly this is greater than 0.8 volt, that is VGS minus VT. And so that is why 1.37 volt is not an acceptable answer. So the correct result would be that VO2 should be equal to 0.73 volt, which is clearly less than 0.8 volt that we initially found as our overdrive voltage, and the value of current for this voltage 0.73 can be found from this expression as 1.27 milliampere.